All right, let's talk about the parabola. So grab your notes and let's work a few problems together. All right, so what's a conic section? Well, a conic section is a curve that's formed by the intersection of a plane and two right cones. So think about two right cones. That was way too thick. Sitting on top of each other, and then like a piece of paper running through them. And let's see if I can sketch it here. So there's a right cone, and then I have another right cone sitting on top of it, and then I have this cut right here in the middle, or not in the middle, but on the side at a diagonal. So when I open that up and have you look at it, if I cut that cone, the shape is a parabola. So if you think about that on the side, the shape will be a parabola when you look at it. And the parabola, we can move it around and open it left, right, up, down. We can actually rotate it, but we're just going to go either left and right, left or right, up or down. All right, so a parabola is a set of all points in a plane that are the same distance from a given point in a given line. The given point is called the focus of a parabola, and the given line is called the directrix of a parabola. So when I graph a parabola, and we're going to work with mostly the vertex at 0, 0. Oops. That line wants to stay curvy. So the focus will be on the inside of the parabola. It always is. And the distance from the focus to a point on the parabola, let's just say this point is xy. And by the way, this distance and then from the focus to the vertex is the same distance to the directrix. So the directrix will be a line, we usually dash it. And then this distance will be exactly the same. This distance. These two distances will be the same distance. All right, so knowing that, let's see if we can write the equation of our parabola whose focus is at 0, 5, and the directrix is at y equals 5. And increase this just a bit. All right. So I'm going to draw a picture of this, and then we'll go from there. All right, so my vertex is at 0, 0. I know that because if my focus and my directrix are the same distance from the vertex, if I'm going up 5 to get to the focus, and that was 4, and I'm going down 5 to get to the directrix, then right in the middle has to be 0, 0. All right. So here's my directrix. Y equals -5. That should say -5. And focus is at 0, 5. Okay, so in order for me to write this equation, well, there are a couple of things I know. I don't know any points that it goes through, so I can't really write my equation like we used to and then plug in the point and find A. I can't do that. But I do know the distance formula, and I know the distance from the focus to some point on this parabola is the same as the distance there, even though it may not look like it because I sketched it. But I know that distance, that is true because that's the definition. So let's call this point F, and we'll call this point P, and I'm going to say XY here. And we'll call this point where this hits, we'll call it D. And that point is some X, and we know the Y is -5. We don't know the X value. All right, so the distance from F to P is the same as the distance from P to D. We know that. All right, so let's do the distance formula. So from F to P, the distance is x2 minus x1 squared. So I have x minus 0 squared plus, now I do my y, so y minus 5 squared. And that's equal to going from P to D. So I have the square root of x minus x squared plus y minus 5 squared. All right, so underneath this, I just have, the square roots can go away. We'll square both sides, so let's go ahead and do that. I'm going to square both sides of this equation. So that doesn't affect anything under the radical, it just gets rid of both radicals. Thankfully, there aren't any numbers outside the radical, so we don't have to worry about that. So x minus 0 is just x, so I have x squared plus, I'm going to go ahead and square out y minus 5. So remember, we write y minus 5 times y minus 5 and then multiply it out, or we also have a shortcut. So y squared minus 10y plus 25 equals x minus x is 0, so I don't even have that. And then y minus 5 squared will be, oh, this is y plus 5, sorry. Maybe you caught that, y plus 5. All right, so it's y squared plus 10y plus 25. All right, so I'm going to clean up now. So I see I can get rid of the y squareds. When I subtract y squared from both sides, those are going to go away. My 25s will go away when I subtract 25 from both sides. So that leaves me x squared minus 10y equals 10y. So I'm going to solve for y, but I'm going to get my y's together. So x squared equals 20y, or y equals 1 over 20 x squared. All right, so there's some things that go into play here. First of all, the focal length is c. So focal length, we represent that with c. And the focal length is the absolute value of c. It's the distance from the vertex to the focus, or from the vertex to the directrix. It's called the focal length. And this number in the bottom has the focal length wrapped up in it. So my focal length is 5. So I know that 4 times 5 is 20. So that's also in this equation. So there's an equation for a parabola. There is a shortcut. There's an equation for the parabola, so we don't have to do this every time. And it's y equals 1 over 4c x squared. Right? And it's the absolute value of c underneath here. The absolute value of c. Actually, no, it's not. It's c. So if c is negative, like if it opens down, c will be negative. So that will make that fraction negative, which will show us that it opens down. All right, but when we talk about focal length, just the distance, it is absolute value. All right, so that means on this next equation, if my focus is at 5, 0, there's my focus, and my directrix is back here at x equals negative 5, then my parabola can't open up or down. My parabola won't ever go through the directrix, and it will always open around the focus. Remember, this parabola is made by looking at points that are equidistant between the focus and the directrix. All right, so just keep that in mind. All right, so that means this is not going to be a y equals x squared parabola. This is going to be an x equals y squared. And remember, it's 1 over 4 c and then y squared. So c is the distance, it's a focal length. So c is 5, because from 0, 0 to 5, 0, that's 5 units. So my equation is x equals 1 over 4 times 5 y squared. So x equals 1 over 20 y squared. So what's the difference in this one and the last one? They open different directions, right? The focal length was the same. They were both 5, but on example number 1, my parabola opened up. Example number 2, my parabola opened to the right. So thinking about those, see if you can work through some of these on example 3. You can pause the video and try these out. So if you didn't pause the video, go ahead and pause it. All right, hopefully you paused the video and tried some of these. So if my focus is negative 2 and my directrix is 2, that means my vertex is right in the middle. So vertex is at 0, 0. Maybe you notice that about all of these. The vertex is at 0, 0. This parabola opens down because the focus is at 0, negative 2. So my focal length is negative 2, so I have y equals 1 over 4 times negative 2 x squared. So y equals negative 1/8 x squared. All right, so on B, you should have y equals negative 1 over 28 x squared. And then if you notice C and D, the focus, the number is in the x slot and the y slot is 0. My directrix is also x equals. So on C, this parabola will open to the left if you want to sketch it. And my equation is x equals negative 1 over 12 y squared. And then on D, x equals negative 1 over 36 y squared. On E, the focus at 0, 3, directrix at y equals negative 3. My equation is y equals 1/12 x squared. And then on F, x equals 1/12 y squared. All right. So I left some space on your notes over here under the examples so that you can actually write questions that you might have, or things that you need to remember, like notes to your future forgetful self, if you need to write some things in there. All right, so now I'm giving you equations, and you're going to find the vertex, focus, and directrix. So all of these, well, A and B, the vertex is at 0, 0, because I don't have parentheses with the x squared. I don't have anything over with the y. So my vertex is at 0, 0. My focus, I'm going to use this number that's in front of x squared. So I want this solved for y. But the number in front of x squared, I'm going to set that equal to 1 over 4c. Now you may be able to tell by looking at it, okay, the ones on the top are the same. So 20 and 4c, what do I have to multiply by 4 to get to 20? C is 5. That's fine. You can also cross multiply. So this turns into 4c times 1, which is 4c, 20 times 1, which is 20, and then divide by 4 to solve. So C is 5. You can also just flip both fractions over and you have that equation. So completely up to you how you'd like to solve that. This parabola opens up, so I have vertex at 0, 0, opening up because this number is positive, so it's A, but that number is positive in front of x squared. So the distance from 0, 0 to my focus at 0, 5 is 5, and so that's C. That's how I got the 0, 5. So there's my focus, 0, 5, and then I'm going 5 in the opposite direction to get to my directrix, and my directrix is the equation of a line, and it's horizontal so that it won't go through my parabola at y equals negative 5. All right, then x equals negative 2y squared, so I know this one is going to open to the left because it's x equals instead of y equals, and then it's negative, so opening to the left. I'm going to do the same thing that I did over here. Negative 2 equals 1 over 4c. I'm going to get rid of the 4c off the bottom. You can definitely cross multiply, which is the same thing as multiplying both sides by 4c. If I put a 1 under here, cross multiplying would just give me 1. So I have negative 8c equals 1. Divide by negative 8. So C is negative 1/8. So that means from my vertex, I'm going 1/8 to the left, and then I'm going 1/8 to the right. All right, so from 0, my focus is negative 1/8, 0, and then my directrix is x equals positive 1/8. All right, C and D are a little more involved. We're going to complete the square on these, and I may need